Welcome to One Time Success, aka Diligent Tutors. Today we will still be looking at frictional force, as this class is the continuation of our last class. In our last class, we have looked into frictional force, the definitions, the types of frictional force, the characteristics of frictional force. We took examples, example 1, example 2. Then we go to the law of frictional force. We talk about the definition of normal reactions. Then we talk about normal reaction of a body on a horizontal plane with a force parallel to the plane. Then we look at the conditions for calculations. We talked about work done in overcoming frictional force. Today we are going to build on our last class by looking at more examples. So let's go to example 3. In example 3, let's look at the question. A force of 300 Newton pull a sledge of mass 60 kg and overcomes a constant frictional force of 60 Newton. What is the acceleration of the sledge? You remember that in our last class, we dealt with this question. Now, the force moving the body is 300. The frictional force opposing motion is 16 Newton. So we have that the resultant force, that is the force with which the object moves, will be the force moving the body, which is 300 Newton, minus the frictional force, which is a resistive force, giving us what? 240 Newton. That is the resultant force. But resultant force is equal to MA, that is mass times acceleration. So we have 240, the resultant force equals to what? 60 kg, which is the mass of the body, times the what? The acceleration. From there, we get our acceleration to be 4 meters per second squared. Now, let's move on to the next question. Now, say an object of mass 100 kg is pushed from rest over a distance of 10 meters with a force of 250 Newton, which acts against a frictional force of 70 Newton. Calculate the velocity when the push ends. Now, let's look at this. The force that is pushing the body is what? 250 Newton. The frictional force acting on the body is 70 Newton. Now, in this case, you remember that normal reaction is what? mg, which is 100, that is the mass, times what? Acceleration due to gravity, giving us what? 1000. So let's again get the resultant force with which the body moves. Resultant force will be 250, the force that is applied, minus the frictional force, which is 70. And that will give us what? 180. But resultant force is what? 180 Newton, which is equal to what? MA. That will give us 180 Newton equals to what? 100A, from which we get the what? The acceleration with which the body moves. Now let's look at the question. The question says an object of mass 100 kg is pushed from rest. Pushed from what? From rest, which means the initial velocity is 0. We have obtained the what? Acceleration. We were given the distance the body was pushed through, which is what? 10 meters. And what is the velocity before the body comes to rest? So we are looking for what? V. So we apply the normal equation of motion, which is what? V squared equals to U squared plus what? 2AS. That gives us the what? The velocity to be 6 meters per second. Now let's go on. Question 5. Calculate the magnitude of the force that is required to just move a 20 kg object along a horizontal plane if the coefficient of static friction is 0.2. Mass of the body under consideration is what? Is 20 kg. So we have the mass to be what? 20 kg. Coefficient of static friction is 0.2, so we have 0.2. Now, normal reaction is what? Normal reaction is ma, which is what? Mass 20 kg times acceleration due to gravity. That gives us what? 200 Newton. Now, take note of this word, required to just move. That is, the body is about to move. Whenever a body is about to move, the force moving the body, which is what? F, must be equals to the what? The frictional force. That's the condition for a body that is just about to move or comes to rest. So we apply that force F. We apply the formula rather. F is equals to Fr, and that's equals to mu mg, which is what? Mu r. So mu is 0.2. Our normal reaction is what? 200. That gives us what? 40 Newton. That is the force we are looking for. Now, example 5, a force of 60 Newton drags a mass of 10 kg on a horizontal table with an acceleration of 2 meters per second square. Calculate the coefficient of static friction. A force of 60 Newton drags a mass. Now, you see that this body moves with what? An acceleration. Now, let's calculate. Let's get our parameter first. Now, the force moving the body is known. That is what? 60 Newton, which means F will be equal to what? To 60 Newton. F will be equal to 60 what? Newton. The mass of the body is 10 kg. So we are looking for we have also the acceleration with which the body moves. Now, whenever a body moves with an acceleration, the force moving the body minus the force opposing the motion will be equals to what? The resultant force, which is always what? Ma. Now, if we look at that, let's go. The force moving the body, 60 Newton, minus frictional force equals to what? Ma, mass times what? Acceleration. 60 minus frictional force equals to 20. From there, we have frictional force will be equals to 60 minus 20. That gives us what? 40 Newton. But frictional force itself in this orientation, that is this plane, is equals to what? Mu r. So we have what? Frictional force equals to mu r. Frictional force is 40. Normal reaction is the normal reaction is 100 Newton, and so we have 40 equals to mu times 100, for which we get our what? Our coefficient of static friction to be what? In this case, supposed to be the coefficient of kinetic friction, that is the body is moving, to be 0.4. Now let's look again at another example. When a bus of 50 kg is given an initial speed of 5 meters per second, it slides along a horizontal floor a distance of 3 meters before coming to rest. What is the coefficient of static friction between the bus and the floor? All right. Since the bus moves with what? With a uniform. Now, since the ball moves, it will move with what? A uniform acceleration. So determine the acceleration of the body before it comes to rest. So that's the first thing we are going to do. We're told that the body is moving. Don't forget that we have a mass 45 kg. We have the initial speed. We have the distance covered. Then the body comes to rest. Let's calculate the acceleration. That is the deceleration bringing the body to what? To rest. So final velocity, because the body comes to rest, is what? Is 0. The body is coming to rest, so the final velocity will be 0. The initial velocity is given to us 5 meters per second, and we have the acceleration, we have the distance. Putting that together, we have the what? The deceleration, because the body is coming to rest, it will have what? A deceleration. So we have a deceleration of what? 25/6 meter per second square. Now that we have the acceleration, now because the body is coming to rest, we have what? A resisting force. That is the body that is opposing the motion. The resisting force bringing the body to rest is given as what? Ma. We have the acceleration to be 25/6. Then we have the mass to be what? 45 kg. So mass times acceleration become 45 times what? 25/6. That is the resistive force bringing the object to what? To rest. But the resistive force will eventually be equal to the frictional force at the point the object comes to rest. So we equate the resistive force to the what? Frictional force. That gives us this relationship. Resistive force is equals to what? Frictional force, which is equals to mu r. Now the resistive force is 45 times 25/6, and normal reaction is what? The normal reaction is 45 times 10. That is, the mass of the body is 45 and the acceleration due to gravity is 10. That gives us what? 450. So we have that 45 times 25/6, which is the resistive force, is equals to the frictional force, which is mu r, where r is 450. So we get the relationship to be, we get our mu to be 5/12. Now let's look at normal reaction of a body on a horizontal plane with a force inclined at an angle to the plane. Now the question we'll be looking at, all the questions we have looked at, the force moving the body is not inclined, it's parallel to the plane. In this case, this is the plane. The plane is what? Red. The plane is red. Then this is the force that is acting on that body, which is inclined to the what? To the plane. So we can see that there is a difference in orientation in this question. The orientations has changed and we have to redefine our what? Normal reaction. We said that normal reaction depends on the orientation of the body, of the force, If the force is inclined, the definition will be different than when the force is parallel to the plane. So the first thing we have to do in this case is that we have to resolve this force. You know, force is a vector quantity. Because force is a vector quantity, it has what? Direction. So we resolve the force by taking its vertical component and what? And the horizontal component. Now, the force, we can draw a rectangle triangle like this. Sorry, not a rectangle, a right angle triangle. A right angle triangle. Let's look at, this is the vertical. This is the what? The vertical. Now we have something like this, and then we have this. So this is the FY, and this is the what? FX. Sorry, this is FS. The horizontal is FS. The vertical is what? FY. Now, you know that the vertical is opposite to the angle, so that will be what? F sine theta. F sine theta, that's what we have resolved here. That will be what? F sine theta. Now, the horizontal, which is Fs, will be what? F cos theta. So we have the horizontal and we have the what? The vertical. Now, as a rule, we must consider all the force going up and all the force coming down. So you know that the first thing we are doing here is that we are resolving the force. The normal reaction is going up, F sine theta is going up, F cos theta is moving toward to the east. So we still have this relationship. So we add up all the force going up, which is what? The two forces that are going up is normal reaction plus what? F sine theta. And the one coming down is what? Which is what? Mg. So taking the sum of the upward force, we will be having what? We'll be having normal reaction plus what? F sine theta. Now, at the vertical, because the body is moving along the plane, at the vertical, which means the body is not going up, at the vertical, the body is in equilibrium. What does that imply? That implies that the sum of the upward force will be equal to the sum of the downward force. So we say normal reaction plus F sine theta, the upward force, must be equal to the downward force, what? Mg. Now, if we make the normal reaction the subject of the formula, we have what? Normal reaction to be what? mg minus f what? Sine theta. So take note that if the force is inclined at an angle to the horizontal plane, the normal reaction is no longer mg, but what? mg minus f sine theta. Now, so we cannot say that the normal reaction is what? mg minus f sine theta, and the frictional force, which is mu r, will become mu into mg minus what? F sine theta. I want you to know that this is the definition of frictional force in this orientation, and this is the definition of normal reaction in this what? Orientation. Now let's look at conditions for calculation again. Now, if the body is about to move, that is showing a tendency for motion, maybe sliding at the verge of sliding, then the force moving the body, which is what? The force moving the body, causing the body to slide, is what? F cos theta. Then frictional force, as usual, opposes the what? The motion. So if the body is about to slide, the frictional force must be equal to the force moving the body. So we have this condition here, which is frictional force equals to F cos theta equals to mu. Now note that this can no longer be what? This can no longer be mg, but what? Normal reaction. But in this orientation, the normal reaction is what? Is mg minus f what? Sine theta. Now, if the body comes to the same condition, we have the force moving the body F cos theta equal to what? Frictional force. Now, how do we define frictional force in this case? We are going to see that we have said that the frictional force is what? Mu r, not mg. Mg here become what? R. As r become mg minus f what? Sine theta. Take note of that. It is not mu mg, but mu what? R, where r is mg minus f sine theta. Now, if the body moves with a uniform acceleration as usual, the force moving the body, which is F cos theta, minus the frictional force opposing the motion, must be equal to what? Ma. Then we cannot frictional force is defined in this case as what? Mu into mg minus f sine theta. So put that together, we get this relationship. So let's look at a good example on this. A 10 kg mass is dragged along a horizontal table by a 60 Newton force. The force is inclined at an angle. Now, the force is no longer parallel to the what? To the plane. The force is inclined at an angle to the horizontal. And the coefficient of dynamic friction between the mass and the table is 0.15. Now, calculate the acceleration of the mass. Now, what is the force moving the body now? That will be what? That will be it will be F cos theta. That is the force moving the body. That's the force moving the body. Now, you know that this body, we are looking for the acceleration, which means the body is moving with what? With acceleration. The first thing we are going to do, we calculate the normal reaction. Since the force is inclined at an angle, the normal reaction is what? Is what? R, which is what? Mg minus what? F sine theta. The mass of the body is 10 kg. The acceleration due to gravity is 10 what? Kg. Now, note that all these questions, we are taking acceleration due to gravity to be 10. Now, what's your question? It might be 9.8. So, 10 times 10 minus the force, 60, sine of the angle, which is what? Sine 30. From that, we get 100 minus 30, which is what? 70 Newton. So, in this case, the normal reaction is what? 70 Newton. Now, frictional force is mu r, which means what? We are going to have mu times r. Mu is what? 0.15 times what? R, which is what? 70. The frictional force is 10.5 Newton. Now, let's go to, that is the, we've gotten the frictional what? Force. Now, for a body For a body, let's first of all look at this force actually moving the body, which is F cos what? Theta. F is 60, theta is what? 30. That becomes 60 cos 30, and that will give me what? 51.9615 Newton. Now, for a body moving with an acceleration, the force moving the body, F cos theta, minus the frictional force opposing motion will give us what? MA. So we have this relationship here. So the force moving the body, F cos theta, is what? 51.9615. The frictional force is 10.5. MA, the mass is 10, that becomes what? 10A. From that relationship, we are going to have an acceleration of 4.15 meter per second. Now, I want us to really practice this example 8. It's not a common question, but it's a question that is always caused for that's always produce confusion to students, because a lot of people always calculate this question in a wrong way. Study it and master it, as it will help you in your exams. Thank you.